Good afternoon, and thanks for joining us for the Science of Caffeine, Chemistry, Consumption, and Controversies. I'm Mac Ingram, Director of Engagement, Alumni and Students in the Office of Alumni Affairs. Since we're virtual, please excuse any issues that may pop up. If you experience any problems with your video or audio, please click the Reconnect button to get back to the webinar right away. Just a heads up, this webinar is being recorded. We will be uploading a replay of it early next week. As a live attendee, you will receive an email with the link once it is ready. Also, if you have a question, make sure you drop it in the chat. We'll have time for a Q&A at the end. Today, we're excited to continue our Science of series with Dr. Daniel Smith. Dr. Smith is associate professor in the Department of Nutrition Sciences here at UAB. He earned his Master of Science in Biological and Physical Sciences and was awarded his PhD in Molecular Biochemistry, both from the University of Virginia. At this time, I would like to welcome Dr. Smith and turn things over to him. Dr. Smith, thank you so much. Thanks for joining us today. We're looking forward to hearing from you.
Thank you for the invitation and opportunity to join you and present here for the Alumni Association. I'm actually pretty excited. This subject has really a lot of facets. I've chosen only a few really to focus on during our time together. As the title indicates, we'll go a little bit over the chemistry, which will be a little more up front. The consumption will be more towards the second half and sprinkled throughout, but also kind of revisiting at the end. We'll hit on the controversies related to caffeine. I have a few disclaimers that I need to share right up front. One, I am not a registered dietitian nor a nutritionist. And as was mentioned, my graduate training is in biochemistry and molecular genetics with a particular focus on the nutrition and genetic interactions as it influences cellular metabolism and aging. And certainly caffeine seems to have some connections there. Number two, I am an avid consumer of caffeine. I have consumed it in various forms, but I've never been a huge soft drink person. So in the recent years, it'd be more in your coffee and teas. And in fact, coffee and tea was consumed during the process of developing this presentation. Number three, as many of you will come across when you engage with science, you should always feel free to question and check for yourself. Particularly things related to intake. I am not recommending that you increase or decrease your caffeine intake habits, but you should feel free to discuss that with your medical professionals if you have any. Lastly, I want to recognize an IT person in our office, Marcy Willis. I had been working on this presentation for several months, and actually this past week was doing some final touch-up. Things got lost. OneDrive doesn't work exactly the way you wanted, but she was very helpful. So here we go. We'll start off with what we're going to be covering. In the prelude to this, I had been reading several books, review articles, different chapters and summaries, as well as some primary published papers. And I wanted to highlight an example of one of the individuals I think that could be useful for everybody in a broader perspective, and that's Michael Pollan's book. He's published on This Is Your Mind on Plants. It actually contains 3 chapters, 3 sections, 3 different compounds. One of them is about opium, the second is about caffeine, and the third one is about mescaline. And in this, he really provides a nice historical perspective, including a focus towards more of the cultural impact that caffeine, and particularly coffee and tea, had during the Enlightenment periods in Europe, as well as in the broader context of the world. So I really do recommend this book as an interesting read if this is a topic that has a lot of significance for you. I provide here a few kind of quotes from the book to get us started. And actually one of them is that, in fact, caffeine is one of the most studied psychoactive compounds there is. So seeing the quote, I decided to check for myself. And what does it look like? Well, if you do a PubMed search, it comes out to about 39,391 articles that have the keyword caffeine in them. However, if you broaden that to actual beverages that contain caffeine, including coffee, there's another 21,000 hits. If you do tea, you get about 45,000 articles. And finally, if you use chocolate, which is not a beverage, usually unless it's in the hot chocolate form, you get another 6,900 or so articles. So it clearly is a highly researched compound, but also a food ingredient that is in a variety of foods that we take. And this gets back to this distinction that we'll come to throughout the presentation of caffeine versus a caffeine-containing food. The second quote here, that the particular quality of consciousness it or caffeine sponsors in the regular user feels not so much as an altered or distorted as normal and transparent. And in fact, I really didn't understand this until I became a regular coffee drinker. And what it belies is the fact that really these aren't significant mind-altering substance in the way that you would put it on a scale. It's just really on the low end, dealing with alertness and focus. But you don't really notice what's happening until you actually remove yourself from it. So if you go on a coffee fast and you don't take any type of coffee or tea or other types of caffeine, you can begin to observing yourself how it has really changed you, but you didn't notice it. And then that leads to the last statement. It's something like 90% of humans ingest caffeine regularly, making it the most widely used psychoactive drug in the world and the only one we routinely give to children. So this actually belies a little bit of the safety, and there's some controversy about different life stages that we'll touch on. But in reality, caffeine consumption is highly prevalent, which gets to a challenge when you really want to understand the science of what are the impacts of caffeine. So where do you find populations where you can randomize people to take in different levels of caffeine when in fact they're already doing that naturally? So these are some of the difficulties that you have in trying to understand what are the effects of caffeine particularly. And as I mentioned with the withdrawal, this was an interesting take on it. Michael himself experimented with removing or fasting from caffeine. And the day's first cup of tea or coffee acquires most of its power, its joy, not so much from its euphoric and stimulating properties than from the fact that it is suppressing the emerging symptoms of withdrawal. In fact, some people refer to coffee in different ways. There's some euphemism or other names for it. And it's referring to this caffeine effect. It's a cup of optimism, concentrated sunshine, the beverage of the modern bourgeois age. And in fact, that was written much earlier than we have for our Starbucks and everything today. And even some famous people who you might know of, say Voltaire, lived 1694 to 1778, is reported to have drank upwards of 50 cups of coffee per day, sometimes and often infused with some chocolate, giving an additional source of caffeine kick. So this has been around for a couple 100+ years. And really the effects as we know them today come down to what have we observed and how can we separate caffeine from all the other things that contain caffeine. And I really like one of the quotes from Voltaire that we'll come back to at the end. Common sense is not so common. And when it comes to intake of caffeine, that is one thing we need to keep in mind. So this is following on Voltaire, who actually, this French novelist Balzac lived right after him. So Voltaire dies, and from 1799 to 1850, you have a French novelist and playwright who was renowned for huge consumptions of coffee and proposed that it might be contributing to his productivity. But it says in this quote, it produces a kind of animation that looks like anger. One's voice rises, one's gestures suggest unhealthy impatience. One wants everything to proceed with the speed of ideas. One becomes brusque, ill-tempered, and about nothing. One assumes that everyone else is equally lucid, and the man of spirit must therefore avoid going out in public. I didn't fully appreciate this until it was probably a year or so ago. I came into work and a colleague walks over to my office after hearing, I guess, the first couple of meetings and said, "Hey, have you had an extra cup or two of coffee this morning?" And they were belying the fact that, yeah, I was probably a little extra hyped, fired up, ready to go for the morning. And it was partly because I actually had consumed more caffeine. So for all of its good or bad, it does seem to have some pretty strong cognitive and focus effects that we'll be getting into. Now, in research for this presentation, I came across a couple of resources in addition to the book that was a great read. Here are some of them highlighted. The first one is the International Food Information Council Foundation fact sheet. When I came across this, everything you need to know about caffeine, I figured, well, do we even need to have a webinar? We could just give this out and let everybody read it. But instead, I've chose to select out a few things here and there and combine it with some other resources. I note a couple of others for you. The Harvard School of Public Health has many of them that are actually available, and one of them is about caffeine, a little fact sheet or summaries that are online, as well as there are some books and chapters. Here's an example of one that is highlighting the characterization and properties of caffeine, but there are subsequent chapters that also relate to it. So what's the goal today? The goal is to learn a few things. Maybe one new thing, maybe a handful of new things that you hadn't really known or considered about caffeine. The second one is to inspire some thought and current understanding about what do we really know of caffeine and the challenges that it presents in our scientific study for this widely consumed compound. Another one is to share information. Sometimes it's great to be reminded of things that we kind of know, but we haven't put together in the same way. And the last one is have fun along the way. So jumping into the chemistry, caffeine, phytochemical. It is an alkaloid, and the naming structure, I provided 3 different alternatives. This can become a little complicated if you actually look at ingredient lists. If they use scientific nomenclature, it could be any one of these 3 examples, but they're all actually saying caffeine. It really is referring to the skeleton structure, which here is a purine. It has 2 different cyclic rings. One of them is a 6-member, the other is 5-member, and they're shared there. And this structure is really important. It actually contributes to a planar structure, and because of the combination of bonds that are available, it actually allows it to interact both with hydrophobic and hydrophilic interactions. So therefore it can get into and pass through membranes, which really impacts the ability to get to the central nervous system and have its primary impacts there. But caffeine, if I ask you a question, and I will, we don't have a poll, so just think about this for a second. Are there any naturally pure sources of caffeine where the only compound is actually caffeine? The answer is no. I'm not aware of any. So caffeine occurs in nature in complex. It is not in an isolated form. It occurs in things like these plants here with coffee. And I'm going to use coffee as an example, but as we'll see in a few minutes, there are many other plants that contain caffeines. Several of those are used commercially and by us as humans for consumption. So in this example here, you have a picture of a coffee plant tree within a grove or a plantation, depending on the size of it here. There are a multitude of species. Those species listed here, it's at least 70. There probably are upwards of 100. However, only a handful of those are actually really cultivated for commercial purposes. Approximately 75% of that production is coming from the Arabica families, whereas another 25 to 30, depending on who you're reading after, is in the Robusta, and they come from different ones. Whenever you're thinking, though, about caffeine, what we're often think about is not the coffee itself, but the constituent of it. But this is a really important point. So if you look at coffee beans and what they're made up of, about 13% of a coffee bean is protein, another 10 to 15% fixed oils. Caffeine really is a minority compound. It's only 2 to 3% of the dry weight, another 3 to 5% coming from tannins. But yet when you say caffeine, we automatically associate it with things like coffee, but they're not equal. So there's this conflation in the literature and in our language about what is caffeine. And you can also note here that in a single cup of coffee, if you isolate and characterize all of the individual chemical compounds that are present in one cup of drip brewed coffee, in fact, it would be over 1,500 plus individually distinct chemical compounds. So I've listed a representative sample of some of the more prevalent ones, but you can imagine I can't make a slide that has 1,500 plus compounds. And the reality is that those distinct compounds change relative to the type of bean, the conditions it was grown in, the roasting process that was used, the brewing process, the water temperatures, the water's acidity, all of these different things. So in fact, whenever we're talking about beverages or foods that contain caffeine, both the amount of the caffeine can vary, as well as the amount of other compounds that may interact with caffeine that are present in those food or beverage items. So it is complex, but we're here to talk about caffeine. However, I want to ask you another question about coffee, because I've already mentioned it has protein and fats. And the question is, does it have carbs? Coffee beans, in fact, do. And if you were to look at soluble carbohydrates, this is surprising to many people, but a drip brewed cup of coffee actually has more soluble fiber than a pulp-free cup of orange juice. Now, where do those come from? Well, in a green coffee bean, before it's been roasted, dried, and everything else, you actually have quite a bit of sucrose and other types of sugars. Some of those are listed here for you. And in fact, heating with the roasting changes both the monosaccharide ratios as well as the total availability. Therefore, whenever you have ground and brewed, you're extracting some aspect of those sugars, and the soluble sugars, particularly coming through the water, are also available. Which leads us to this. If you pull up a nutritionist fact sheet, you may have all seen one of these before. On the right of your screen, you will have a label. This is available on food items that are for purchase. We can walk through this very quickly. Many of you will be familiar with it. You notice at the top, this is 1 cup, an 8 fluid ounce, or approximately 237 grams of coffee. So this is brewed coffee, the cup, not the bean, but the actual coffee drink. How many calories? Virtually none, 2.4 calories. And this will range. Some different types of coffee preparations will have slightly more. So like if you do a French press versus if you do a drip brewed, it could be upwards of 4, maybe even a little higher. But notice that even though on the previous slide there were proteins, fats, and carbs, really there are very few fats, total fat, no cholesterol, a little bit of sodium, very little fiber, even though, like I was telling you, there is some soluble fiber that gets through. It's just not a high quantity, and orange juice has even less. But then at the very bottom here, caffeine. So in 1 cup of drip brewed coffee, you have approximately 94.8 milligrams. And this is approximate. Most people use a range somewhere between 80 and 100 milligrams for caffeinated coffee. There are also many other compounds that don't make it to this list, and mainly caffeine being there because it is a requirement for disclosure. So the question becomes, where do all the other compounds go? What happened to all the fats and the proteins and the carbs? And if you were in person, I will let you answer. But to remedy any type of suspense, the reality is that we use grounds, the coffee beans that have been roasted and ground, and then discard those. And in fact, many of those other nutrients are left in the grounds and are discarded and not incorporated as part of the drink. Therefore, the brewing process itself and how much of that is trapped even in the filter paper or the type of filters that are used versus no filters with some other type of mechanized really does make a difference in the final composition, both of the coffee itself, but also potentially in the caffeine that gets through. All right, so moving on here to the actual chemistry, we've already mentioned that it was an alkaloid that is purine structure, and there is actually a shared chemistry of purine metabolism and production across many different cell types. For plants, though, making it down to caffeine production, but you'll notice here, and I highlight 2, and mainly because I want you to see that caffeine in its structure here with those 2 rings actually is a shared component of another structure you may have heard of before, AMP. So AMP, ADP, ATP being the energy currency of the cell. This actually gets back to how many ways that caffeine can interact with cellular signaling within the body. We are not going to spend a huge amount of time talking about every single receptor, every single pathway, every single metabolic component, but just to be aware that actually at the chemical level, the structure of caffeine and some of the related compounds, which I'll show you, do have some mimicking effects for some very prevalent, highly important energetic sensing factors, as well as neuro signaling factors. So it does have a resemblance to adenosine component of the AMP. Also, I show you on the right here a pile of white powder. This is often confusing to people, but if you take purified caffeine and only caffeine, it is actually a white powder. So why in the world do we have in coffee and in tea and in chocolate and pretty much every other source, why does it come out brown? lots of other compounds, including minerals, but also proteins and stuff in those actual sources, as well as tannins and polyphenols and things contribute to the color. The caffeine itself, though, in its purified form is actually white. I only mention this because I've seen actually some advertisements for party caffeine. So you can get it in supplements and pills. You rarely can buy it in powder, but there are actually teenagers that are using the white powder for parties nowadays. So be aware there are different sources, and you should be careful about the really high concentrated forms. All right, so caffeine, what happens whenever you consume it? I just showed you that there's actually a lot of pathways that have the ability to convert purines, and in fact, your body breaks it down. The cytochrome P450 detoxification pathways, which are important for both xenobiotics as well as phytochemicals, drugs, everything, it can convert these to different forms. Well, what's really interesting is that caffeine through these pathways gets converted to forms that are also present in coffee. So just like caffeine is in coffee and just like caffeine is in chocolate and teas, theobromine is present, but theobromine is also a breakdown product of caffeine. So sometimes whenever we're talking about the effect of caffeine, we may also be talking about the effect of caffeine with all or some amount of its downstream breakdown products, which could also have effects on people. The half-life for caffeine, so if you absorb caffeine and then you begin to degrade it, it's estimated to be approximately 5 to 6 hours. However, this is variable between individuals. So whenever they drink the same amount of caffeine, or even if you take a caffeine supplement that is just pure caffeine, the effect, how quickly it affects you, will be based on the absorption, and how long that effect lasts will be based on your ability to metabolize and clear it. And we'll come back to that here towards the end. So consumption, well, it's a naturally occurring phytochemical, right? It means it's been in foods that have been either eaten, like in chocolates, or drank through teas and coffees and other forms for actually many decades, sometimes century or even millennia. So is it safe? The United States Food and Drug Administration classifies it as GRAS, which means generally recognized as safe. There are a couple of ways you can be included in that designation. One of those is that the ingredient safety could have been established before 1958, and based on a history of safe use and consumption of significant number of consumers, there's no reason to change that. Or two, scientific data and information about the safety and use of the ingredient is widely known and publicly available, like through scientific articles, and there's a consensus among the scientific experts that the ingredients are safe for the intended uses. And in fact, in the United States, moderate consumption is approximately 300 to 400 milligrams per day. That's roughly equal to about 4 cups of coffee. And we don't even really hit that on the average consumer. In 2014, that's about 165 milligrams per day. So in that 1958, the American Food and Drug Administration did actually recognize caffeine as generally recognized as safe. But there is a little caveat here. So caffeine related to colas actually has a limit, and those have been visited as caffeine has been added to different types of drinks. So sometimes a GRAS designation is for a particular amount and form, but just because it is for that doesn't mean you can now take caffeine and add it to an alcoholic beverage and it still be considered GRAS. So there have been some nuances to this, but in most forms where caffeine is a predominant ingredient in the beverage or whatever, it is still recognized as GRAS. So we've already talked a little bit about caffeine versus a caffeine-containing food or beverage. There are a few highlights here to make. One is that tea is probably the oldest known vehicle that contained caffeine. It's been consumed for now, what is this, almost 5,000 years, at least based on records going back through China. There are different forms of teas, which we'll touch on. Coffee, a little newer, but still the beans versus the drink or a beverage where you took water and extracted something from the beans. We still have, 1,000, 1,500 years of consumption there. But in Europe, the actual adoption and use of those really only happened after the 1500s, maybe slightly earlier. But it really became revolutionary because these other places had used the caffeine beverages for different purposes, but really not the same way that Western civilization adopted them. And interestingly enough, many of these actually arrived at the same relative time period in history for Europe. That was largely because of exploration and trade. So just as well with the coffee and the tea arrival, you also have chocolate, which contains caffeine, as well as some other things from the Americas that eventually were brought over, which we'll touch on. So what does this matter? Why does the time in which it came to Europe? Well, actually, this was during the period of scientific revolution that was happening, particularly in France. And you actually have a unique situation, and Paulin deals with this in his book, but other authors have where really sanitation wasn't fully understood. So we take a lot for granted in the modern age, where we live in a society where we have seen the advances of science, we understand, but think about it, germ theory really wasn't present until the late 1800s, and trying to understand why was there so much sickness in different types of consumption. So actually water and how it was treated and its impact, coffee and tea, because you boiled the water, there were a lot of health related effects that were observed, which were associated with the drinks, but were also partly, it looks like, present maybe because of the sanitary practices that were adopted in the preparation of the drinks. So really interesting if you want to follow that history and take a look at the uniqueness of how the actual production of a beverage that contained caffeine had indirect health effects that weren't really part of the primary purpose, but nevertheless occurred. And it was really because of the ability to collaborate and share and trade, as well as some other issues of international exploration. All right, so let's go through a list here for consumption. We have a table. This is referenced there at the bottom. Caffeine comes mainly from plants. Again, you can chemically produce it, but if we're talking about natural sources, it's in the pure metabolism of the plants. In this table, you'll see on the left the actual plant source. On the third column, you'll see the caffeine content on a dry basis, meaning if you take whatever that final product is, if it's the bean or the seed, and you weigh it and then you extract the caffeine, how much of that weight, of the dry weight, is actually caffeine? How much is produced on average per year? These data come from 2015. So this would be still relatively in the ballpark. And then its uses. Notice quickly that in the amount of produced per year, clearly coffee is the winner, whereas about half that, a little bit more, coming from the secondary source of tea, and then chocolate right behind it. Whereas these rarer forms also have caffeine in them, but they're not as commonly used, and particularly not as commonly used in the US, with the exception maybe of cola. So walking through these from top to bottom, guarana actually is coming from South America and was used as a stimulant, is known to have the similar types of effects of coffee itself, but it does have caffeine. Tea, we've already mentioned. Coffee, we've mentioned. The cola nut, you may have heard of Coca-Cola. This is actually a nut that comes from Africa. It was used in the ground form. People would chew it. It was a stimulant, had all kinds of proposed health effects, but it was actually used in the development of the formulation for Coca-Cola, and it became a source of actually caffeine for that drink early on. Then you have mate and then chocolate. Each of these in the late 1800s had caffeine isolated from them. So in 1819 and then again in 1822, caffeine was isolated from coffee. 1826 from guarana, 1838 and 1840 from tea, 1836 from mate, 1865 from cola, and 1883 from cacao for the chocolate. So really that period of the 1800s had a lot of chemical advancements and the ability to extract and identify different types of compounds. One interesting story about this is the individual who is credited with identifying caffeine from coffee. It almost seems like it's by happenstance. So he had the opportunity to meet with one of the leaders in the day at Goethe, a poet, Johann Wolfgang Goethe. He had changed from a literary figure to a more scientific botany focus as he got older in life. And Friedrich Ferdinand Runge, who was a kind of self-taught in some ways, it looks like, but very interested in pharmacy and chemistry, had come up with an extract from the belladonna plant, which has atropine, and had the ability to add it to cats' eyes to cause dilation. Goethe was interested in this phenomenon. He knew, kind of like a mentor to Runge. He went over, demonstrated the effect, and in the process, Runge, who has this really strong chemistry interest, is given as a gift because of this demonstration. It looks like a packet of Arabian coffee beans. It says this might be of use to you if you can understand what's in it. And sure enough, Runge used it to identify caffeine shortly thereafter in 1819. So bringing together access to the actual beans as well as the chemical ability to kind of isolate compounds really turned out favorably. And, it was actually almost 80 years later, 1897, when Hermann Emil Fischer determined the chemical structure, not just that there was caffeine, but actually what was the chemical structure of it. And when he was given, I think the second year of the Nobel Prize in 1902, was given the Nobel Prize for solving the structure. So we talked about they come from all over the place. Exactly where do they come from? Coffee. Here's an example in this map showing the different countries and regions where coffee is most highly produced. And it doesn't take much to very quickly look at this. The darker colors, there should be like a bluish gray and then a brown color. The brownish colors are the regions that produce the coffee. This is cultivated usually at an altitude of approximately 1,000 to 2,000 meters above sea level, so on mountainsides, ranges. Particular places it's more indigenous would be Ethiopia, a little bit in Brazil, India, Mexico, and a few other locations. But by and large, these are running along, you'll quickly notice, the equator, and they're kind of bounded by the Tropic of Cancer and Capricorn on either side. So very tropical regions per se for growing it. And as we move forward to tea, that's not wholly different than tea, except for the real expansion into Asia and China, where it was highly grown and utilized for centuries. And finally, an example here with the cacao, again, the chocolate. So showing that too also runs highly along the equatorial belt and growing in similar regions. So what this really brings us to is the fact that in Europe and in the United States, we've actually become very dependent in some sense on these food sources for beverages that we really don't grow ourselves. And this became part of the controversy, actually, in the establishment of some of this with the colonialism that occurred out of Europe and bringing the products, but also not in how they did not treat the peoples that were growing them as appropriately. So production, not in the places that really do rely on it for consumption, but it is readily available through markets, and that is a good thing, I think, for us. So the question often comes up, okay, well, we in many types of cells can have pure metabolism. Well, why do plants make caffeine? It is clearly a secondary metabolite, which means that it's not essential for active growth. So what role does it have? Well, it does appear if you extract caffeine and you do a whole bunch of studies on its different properties, it does seem to have a chemical defense aspect to it, meaning that insects that would attack the plants or the fruit, it has an offset or a lethal effect on them, the bitterness and the caffeine-specific effect. Allelopathic, meaning that the caffeine is present in different parts of the plants, and even like the leaves and stuff, as they drop and degrade around the plant, it does appear that they contain some herbicidal type properties which may compete out for different types of weeds that would grow otherwise around the area. And caffeine itself, as well as some of the other compounds that are in the plants, like the tannins, can have bioecological properties, including on the microbiome. So there may be a whole host of things that are interacting And it's not that the plant is making the caffeine for us per se, but there could be some cross benefit for having caffeine in the plant and its effect on both the animals or including us that are consuming it. So related to consumption, where do we get most of it from? Here are a few lists, and I've only included highlighted pictures. There are hundreds and hundreds of different types of forms that you can take in now. Most caffeine is still consumed orally as a food or a beverage, mainly as a beverage. However, you may have come across caffeine gums, as well as gel packs. If you don't like either one of those by the oral route, they have developed caffeine patches, so you can take that dermally through the skin. I don't have a picture on here, but some of the e-cig or other type of vaporizer type things are available now that also have caffeine in them, so that would be through the lungs. And finally, as a supplement, so purified caffeine can be synthesized as well as extracted from natural sources, and therefore you can take caffeine as a pilled supplement or as a dissolved concentrate, which can be added. So one of the questions that comes up is, well, what is the highest amount of exposure? If I had to choose, like, which one of these, and let's just make it easy, we'll go down to a beverage form. Which beverage has the highest amount of caffeine in it? You're welcome to submit something to the chat if you think you know the answer. Clearly, I've listed or shown here in the picture a whole bunch of the energy drinks. And in fact, many people often will think immediately, well, it's got to be one of these energy drinks, because I've heard, that there's some type of high levels of caffeine that can be dangerous. But in fact, if you consider a single type of beverage as the serving size of that beverage, turns out Starbucks 20-ounce venti Pike Place roast looks like it probably has the highest amount in a single consumed source. That runs approximately, and again, it's a 20 ounce, so take that into account because many of the energy drinks are at 8 ounces, and that's the unit of serving size. It's about 410 milligrams of caffeine, which is surprising to many people, including myself. If you were talking, and I see a lot of suggestions there about the actual energy drinks, there are a handful that are higher than others. The Celsius, Rockstar, Bang, Redline Extreme, and A-Shock all have individual versions of their energy drinks that tend to have somewhere in the range of 300 milligrams per can. Therefore, on a concentration basis, it would actually be higher than the Starbucks because of the serving size. Red Bull is one of the top selling. Obviously, you've seen a lot of sponsorship from it, and it's concerned they're about teenagers and they're taking high amounts of it. And it should be noted, and we'll come back to this in a minute, that many of these, both coffees and energy drinks, have a high amount of sugar, and we'll go into the reason why. So it's not just that you're getting an energy boost from the caffeine, sometimes you're also getting it from a secondary source. So if you wanted to show this on a graphical or table format for the relative amount of caffeine, I've kind of taken two nice graphics here that organize this for you. Notice that a decaffeinated cup of coffee has still a little bit of caffeine. Most of it's been removed, 3 milligrams approximately for the same serving size that a fresh brewed drip cup of coffee would have 95. So 90-ish% of it removed. Similarly, hot cocoa, lower amount than, say, the teas, but even among the teas, the type of tea, whether it's the white tea, a green tea, a black tea, really does make a difference. And these are just representative numbers. In fact, like I mentioned before, the amount of roasting, the longer the roast, the less caffeine. So the heating of it actually is helping to break down some of that. So really dark roast actually has lower caffeine amounts than a light roast. Similarly, the type of bean, Arabica beans actually have less caffeine than the Robusta beans. So depending on the sourcing of it, everything else, you can have ranges, but these are showing you the typical and then the overall range. The decaffeination process itself is very interesting. I won't spend a lot of time on it here unless somebody has some questions later. But there has been concerned, is it a direct method, an indirect method? Because there's a little confusion sometimes. Decaffeinated coffee beans don't really exist as a plant. Usually the caffeine is present, you have to get it out of the bean. And in fact, that usually uses some type of chemical process. So therefore, there have been concerns, but most of those have been set aside over the years. However, some people still argue there's the better ways to do the decaffeination process than others. So what does it look like for consumption for people? There are two graphs shown here. Both of these graphs show data for the United States, and the source is there for you. These data are coming from the NHANES, the National Health and Nutrition Examination Survey. The cycles that were used in this particular paper come from the years 1999 through 2012, which is a total of 7 cycles because they're 2 years each. And this particular consumption data for these graphs is showing the years 2011 through 2012. The amount of caffeine is shown on the y-axis, and on the x-axis, the first column is the total. So if you take the whole population that was sampled, and these are very large nationally representative samples, and then break that out by age group from 4 to 8 years old, 9 to 13, and going across, you quickly notice that actually caffeine intake increases. Early age, lower amounts. As you get older, higher amounts, and then drops off again as you get past the ages of 70. That the types of caffeine, or the sources of caffeine, so the color codes, in case you can't see it well, the blue is coffee, the green is tea, and the orange is soda. They make up the majority of the intake for the different individuals. And that proportion changes, as you'll notice on the right graph, as you look at the percentage of the total, where you're normalizing now and kind of removing the effect that you actually increase the amount of intake, absolute intake per decade going up in age. Actually, the proportion changes too, and there's more coffee consumed at older ages. So chemistry and the consumption really are the focus, but it would be derelict not to talk a little bit about the effects. So what effects does caffeine have? Caffeine really is most well known probably for its psychoactive effects in the alertness and cognitive function arena. So on the right here, you see that actually caffeine interacts with the adenosine receptor and increases wakefulness. On the left, caffeine, though, also can interact with receptors in other parts of the body and can contribute to vasoconstriction, which, as you might imagine, will have effects on blood pressure. Similarly, there are receptors of other types. We won't go into the details of all of them. If it comes up in the question, happy to address them. But it can have effects in GI, increasing acidity in the secretions in the stomach. It has metabolic effects. You might expect that both from the heart rate, but also it has metabolic effects from the actual substrate. So change in lipolysis, change in glucose uptake, and hepatic glucose production. And it also has effects on the kidneys with function, as well as the lungs. And in fact, it's not just caffeine. As I mentioned before, some of the breakdown products of caffeine also have these similar effects depending on the receptor and the particular organ or tissue. I kind of hinted at earlier, absorption really makes a difference as well as metabolism. This is kind of showing the idea that we often think, well, I just had some caffeine, so what's the effect going to be? Some people say, well, I can't have it past X time in the afternoon because it keeps me up at night, right? So I can't have it past noon because I'll be awake at 12 o'clock. Other people say I can drink it 9 o'clock at night and go to bed at 10 o'clock and not a problem at all. Well, part of that is related to the cumulative dose. So in a half-life estimate, and these I'm not necessarily saying are great resources for all details, but it has a nice graphic in both cases. As you take in your morning cup of coffee, it goes up in levels. You had 100 milligrams in it, but then you get to a blood level. And as you start to break that down, again, the half-life being somewhere in the 5 to 6 hour range, if you have another cup of coffee at noon, you still have some of the caffeine in your system from your first cup. So it builds to a higher level, but then as you stop drinking coffee, your body is eliminating that still at a similar rate. But that rate is very variable depending on your genetic background, the cytochrome P450 enzymes, as well as what else you've had, your diet, how active have you been, what are different hormones in your body that are interacting with some of these same components, alcohol, other compounds. So it is not a simple formula where you can say exactly for any one person, this is going to be your blood level if you drink this cup of coffee at this time. And it also is true that you will not be able to predict exactly when the stimulation will peak or when it will completely resolve. Hence, there are some issues about how soon should you take it relative to bedtime, which gets to the pros and cons. So this is a nice little graphic. You'll have it available in the webinar, so you can go back and look at it in more detail if you would like. A lot of times we want to focus on the good things. There's a list here of some of the diseases that have been proposed to have links or associations with cancer, with coffee consumption in the reduction. So for instance, right here in the middle is cancer, but Parkinson's and Alzheimer's, both neurologic disease, type 2 diabetes, gallstones. On the flip side of this is the negative sides, and this is what you might expect, that you can have changes in sleep patterns. If you have already blood pressure issues, could there be an issue about an additional rise in blood pressure? If kidney function is affected, is that also an issue? So it's not an easy answer to say, is caffeine okay? And again, in this case, we're talking about coffee. If we had tea here, which also contains caffeine, you might have a slightly different ratio or breakdown of the pros and cons. If you're talking about chocolate, you might have a slightly different. Overall, though, the patterns are pretty consistent. But be clear, this is coffee. This is not just caffeine. Which gets to this next one. Whenever you then look across large studies, there's a lot of systematic reviews that say caffeine intake is okay or caffeine intake is not okay. But in reality, they're really talking about a beverage that contains caffeine. And in most cases, they're not doing a randomized trial. And part of that reason is if 90%-ish of people are consuming some amount of caffeine already, it is very difficult to find a population where you can then say, we're going to randomize you to either have caffeine intake or not have caffeine intake, because most people already do. So the fewer studies that you'll find that are randomized controlled trials are actually ones of reduction of intake and looking at effects. In this particular example here, instead of just saying there is a relationship with coffee intake and neurologic disease, they're actually quantifying it. They're saying an 8-ounce cup. So if you have 6 cups per day, the blues are the benefits or the pros, the reds are the negative trade-offs or the cons. And they're arguing that based on the literature and a 20-year study of 50,000 men, it lowers 6 cups of coffee a day, lower the risk of advanced prostate cancer. But again, these people were not randomized to drink 6 cups. They just voluntarily were consuming 6 cups versus a population of comparators that were non-consumers, which are unique because most people are consuming some amount of caffeine, maybe not always from coffee. Here also 5 cups, lower risk of Alzheimer's, 4 cups, stroke, diabetes, 3 cups, gallstones. But in this lower range, you also see this note here about potential miscarriage. Here, anxiety and jitters, upset stomach, and finally, even fatigue, headache, and difficulty in concentrating. Hang with me, we're almost done. So what about the controversies? We've mentioned a little bit of them along the way, and now we're going to come back to a few of them. One of them here was at the bottom. Clearly, this was accessed in coffee, tea, chocolate. All of these came from regions outside of Europe. And colonialization was an issue. Slave labor, land use, equity and justice for wages, and all those other things. Many of those have started to be addressed. They haven't necessarily been fully historically corrected, but they are something to think about. And in fact, today there are many organizations that are trying to set standards. You may hear of fair trade or other types of organizations that are involved in the process. There are 3 others that we also should highlight. We already mentioned one about added calories. So here, these are sugar cubes on the left. 2, is there potential then if these have cognitive alertness functions with sleep about circadian disruptions? And 3, about potential toxicity. So moving through those quickly. Added sugars. One of the aspects of caffeine, as well as other compounds that are present in coffees and sometimes in teas, is that they have a very specific bitterness profile. And in fact, caffeine is often used as a standard in bitterness rating scores. So here are 2 graphics that we'll go through quickly that are comparing the amount of sugar. Sugar can be used to offset bitterness And in fact, if you look at the natural versus added sugars, as I mentioned before, most of the sugars are not coming through in a black drip brewed cup of coffee. So at the top left, a coffee black is actually having 0 of natural sugars. If you add a little milk, there's going to be some lactose. And then if you add a double and you're putting in added sugars, you've now got 19 grams of sugar per 16-ounce cup of coffee. So half that if it were an 8-ounce cup. As you move down this chart, the gray is the naturally occurring sugar. The red is the added sugar. So if you'll notice all the way at the bottom here in a cafe vanilla frappuccino, you have 12 grams of natural sugars coming from the milk sources, and then 55 grams of added sugar, which is a lot. And you say, how much is that? Well, the graphic on the right helps scale that. So going from the bottom to the top, the black drip brewed with nothing added, all the way to this highest amount with the cafe vanilla frappuccino. Any of the circles here, you have a female and a male shown with the amount of recommended daily added sugars in the diet that is acceptable, the minimal or the maximum amount. If you are in red, that means that you have hit it or you're over it. So in this case, 55 grams for a female is 275% of the recommended upper limit of daily intake of added sugars from one beverage of a coffee. My guess, I haven't done this experimentally, my guess is if you gave people that same drink and then allowed them to add sugar to that, I doubt they would add 13 and a half packs of sugar to that drink to make it palatable. And I know that there are efforts underway to reduce added sugar. So that I think some of these things will change, but be aware, sometimes coffee is thought of as a health drink. But if you start getting huge amounts of caffeine, stimulate you, yes, huge amounts of sugar. Well, your body's not going to deal with that. And some of those processes are being altered through the caffeine, but they're both actually sort of addictive, right? So it can be feedback to make you want to have more. Mentioning then back to the circadian effects, clearly caffeine can have effects on alertness, sleepiness. That's part of its uses in the military, the caffeine chews. Great, wonderful things. But the reality is that caffeine came along about the same time that a lot of other things did. We have now indoor lighting at night, electric lighting, right? We have phones. We have all kinds of devices that take us away from the natural circadian patterns that used to exist in our daily experiences, which have been related to the metabolism that we should normally exhibit based on light, dark, feed, fast cycles. And now with the addition of caffeine on top of all those things, there is a question about how much disruption are we causing, and is this harmful in the long term? Toxicity. Well, if you have too much, it clearly can have anxiety effects. Part of that's through its mechanism, neurologic and jitters. There's questions about pregnancy. The summary I'm going to give you is that, in essence, again, there really are very few, if any, randomized trials, and those are usually on the reduction side. The association studies do say that, yes, caffeine can get across the placenta and it can be transmitted in breast milk. So does the caffeine intake of the mother impact? Yes. What should be the amounts? That is more disputed because the sources that have been tested and everything else occur usually in a beverage of some sort, and they're variable across studies. Contaminants. These are plants. These are grown in all kinds of conditions. You may see on coffee or teas or some of these other sources nowadays that they're organic certified. Well, part of that is because you can have residual pesticides. You can have other compounds that are being picked up from the environment. There are processes that are employed by the major manufacturers to try to monitor these things. It is also argued roasting and brewing will kind of reduce those because it breaks down many of the products, but that still is a risk. And I don't know that we fully appreciate and understand how complex that is for today. Lawsuit example, just in case you've seen it, this is a risk. So there's been wrongful death suits brought to Panera. They are based on this charged lemonade, and the charged lemonade has caffeine added to it. Lemons are not a natural source of high caffeine. And in fact, they argue that there should have been better labeling. Here's a picture of what those machines used to look like. I don't know how they've been modified most recently, but this lawsuit is very recent, back in January. And the argument is that because it's not regulated and how much you could take, you could actually overdose on caffeine. And unfortunately, some young people who have had some existing heart conditions or other things seem to have had some negative reactions and may have passed away. So just be aware there are some risks there. for particular health states. So, summary. Caffeine. There are pretty good data that says you can think faster, but unfortunately it will not make you smarter. Caffeine, it does seem to improve on focus and concentration. It does seem to improve particular types of concentration, so more linear, but not necessarily creative thinking. And sometimes the terminology is used as spotlight consciousness versus a lantern. So things, if you really need to focus and get a lot done, I know people who've used it for all kinds of purposes, study aid, you name it. And even like I was giving, there are examples in history of huge consumptions. It does have mental and physical performance effects, and to some degree, those are advantageous. So, is it really true that maybe caffeine is perfect drug not only for the age of reason, enlightenment, for the rise of capitalism? I'd say I don't know. It's one of the quotes from Paulin's book, but I do know this. One of the most common questions I've had whenever people find out I was on this presentation was the following: if you're doing this presentation, is there anything you're going to be telling me that tells me I should not be drinking or consuming caffeine, right? Are you going to really discourage me for that? My answer is the following, and it's very simple. It goes back to that common sense. The choice really is up to you. If you have a medical condition, talk to your medical professional, but otherwise, think about it. And if you really want to think clearly and take this issue of matter, what are you going to do about your behavior caffeine intake? I recommend you have a cup of coffee so you can think clearly, think logically before you make that decision. And that's the end of the presentation.
Dr. Smith, that was awesome. Thank you so much. We've definitely had some questions come in. I know that was a lot of information. I do wish you would have said that the more caffeine, the smarter you were. I would have gone and grabbed a Coke. Probably not the right caffeine though. But let me go to the chat right now and look at some of these questions. So I'm in my 70s and drink 3 cups of coffee each morning. I get headaches when I try to limit it. Why would that be?
It could be for a number of reasons, but it is known that caffeine has vasoconstrictive properties, and that part of the withdrawal symptom is potential headaches. So not having that could actually be interacting with a neurologic experience that they're exhibiting. With anybody, same issue as mentioned in the disclaimer, it's always good to talk with your medical professional just to make sure there's nothing else going on. But caffeine does have vasoconstriction, and it's actually part of analgesics. So there are headache medicines that actually use caffeine with pain relievers to improve headache responses.
Interesting. Did not know that. All right. The next one is the caffeine in a green tea molecularly different than the caffeine in coffee?
No, really, the caffeine itself, the structure is defined by its chemical composition. There are other compounds, there are other polyphenols or other alkaloids. There are many other differences between the teas and the coffees. And even, again, like I was saying, depending on the growth conditions and stuff. Caffeine, though, if it's being called caffeine, it is a very specific designation of a chemical molecule.
Awesome.
Compound.
Okay, it is my understanding that caffeine raises blood pressure. Is this true? Is it temporary, or does long-term use result in long-term elevated blood pressure?
So acutely, yes, those have been observed in studies. That is what you'd expect from the binding and the receptors that are involved. So it can raise blood pressure. Whether that produces a long-lasting chronic effect that persists after stopping, I don't think so, but I don't know for certain. I would have to look more carefully.
Gotcha. I've heard that tea increases the odds of a kidney stone, not from the caffeine, but other components of tea. Do you have any comment on that?
So there are, and this is part of the potential contaminants or other types of effects and toxicity. So again, we assume a lot of times when we're talking about a beverage that contains caffeine, that's what it is. So if I remember right, and again, I'm not an MD, but oxalic acid and some of the other components that can contribute to kidney stone formation may be relevant. And some drinks are actually discouraged if you have a history or an existing one. So that would be an easy question for your physician to make sure. Sometimes, and this is the thing that happens. So my dad's allowed me to give this example. He has a heart condition, and he's talked to his doctor before, and they've asked him, like, well, what are you doing? All of a sudden he gets out of rhythm, and he's like, well, I'm not doing anything different. I'm not, blah, blah, blah. I didn't change my meds, didn't change my diet. But then if you really drill down to the details, you find out, well, he wasn't feeling great, so he took some zinc supplements, and then that was interacting with his calcium blockers. But he's like, why should I tell him that? It didn't matter. And I think a lot of times we limit the information we share with our physicians when we should be more open. And if it's a question, that's what they're there for. They would love to try to help.
Absolutely. Great advice. As a registered dietitian, I come across a small number of people, including myself, who do not feel the usual stimulant effects from drinking coffee, even in the form of espresso. Could this be related to absorption?
Yeah, so that's a hard one. And different people have highly variable responses. It could be anywhere in that chain, from the absorption to the binding, specific variants in some of the receptors, clearance, all these different types of things. And it is really hard to say. And in most studies, that's not always accounted for. So in other words, if you look at these big studies where they say this number of cups of coffee, what else it doesn't tell you, did those people get the same caffeine response? It just says they drank something, and you don't know the caffeine level. So it is highly possible that some people are very much resistant or insensitive relative to others.
Gotcha. Is instant caffeinated coffee as beneficial nutritionally as brewed coffee?
I don't remember how many studies have actually compared them head to head. And again, it probably depends on the exact question. I don't discount that there are a lot of associative studies showing potential benefits of brewed coffee, but they're within limits and ranges, and there are trade-offs. Instant coffee, if I remember, instant coffee consumption is much lower today than it was historically. So I don't know that there have been recent studies that really would address that well, but I honestly have not detailed searched that particular question.
Yeah, absolutely. I'd be interested to know why iced tea increases the milligrams of caffeine.
Don't quite understand the question. Is it based on the, like, thinking it's more than like in a hot tea?
Likely would be my guess, probably comparing the teas.
Yeah. So there's a couple of possibilities there. And this is also true for coffee. So the preparation method really does make a difference. So if you are drinking an iced tea, many of those are actually from black tea. So black tea would be different than a green or a white tea. But often with iced teas, they're heated for a longer time and then maintained with the ability to dissolve sugars at a higher temperature. So you're actually changing potentially the extraction processes depending on how, and so the brewing for certain types of teas may be very short versus longer. So there's a whole bunch of things that can alter that. But my guess is if you were directly comparing, it would depend on those characteristics of how long you're actually extracting in the brewing process and the type of teas that are involved.
Absolutely. I think you touched on some of this, but can caffeine impact people differently who are on stimulants for treatment of ADHD?
So any type of interaction is possible with existing pharmacology or even other compounds. So same issue with coffee. You know, what else are you consuming caffeine with? If it's in coffee, if it's in tea, it's got the sugar, but what else does it have? Or what other types of things are in your diet? Or what other types of supplements are you taking? And unfortunately, there are not a lot of studies that do that well, but it's certainly a possibility.
Awesome. Along the same lines of the instant coffee, but when talking about K-cups, are we actually consuming the same amount of caffeine as the brewed coffee?
Yeah, I don't know that. I don't remember looking at a particular study that directly compared those two. Yeah, it is a good question. I would not be surprised if you're actually in the same range because of the methodologies and stuff and the amounts of grounds that are used and everything else. But I don't have a quantitative answer that could verify.
Absolutely. Gotcha. Can caffeine affect bowel movements?
Yeah, so GI tract definitely has some effects, both upper and lower GI tract, and it has been used it's been used to affect bowel control, both from the upper end orally and from the lower end. So, yeah, there's.
Awesome. What amount of cups of coffee is considered not problematic?
So if you go based on the U.S. recommended moderate intake upper limit, they would say 4. Some people would say upwards of 6, and it depends on the brew and the size and the definition of a cup. Most people haven't really actually checked what size is their coffee mug relative to cups in ounces, and many mugs are actually much larger than a single cup. We just don't think about it that way. So, if you go by those guidelines, you're probably in that middle range. There are some people, though, that, like, I wasn't joking about that example. Historically, there have been some people that intake huge amounts and doesn't seem to have an immediate, overt negative impact. I know personally, if I get above about 8 coffee mugs, which is probably more than 8 cups, probably closer to the 10 to 12 range, I feel effects that are not necessarily all positive. So that has happened before, and I've realized it. And it's variable.
Yeah, absolutely. All right, just a couple more questions, and then we'll get you out of here. What is the relation between caffeine and PVC's premature ventricular contractions?
So there are some data about different types of health interactions, but I do not know them all, and I would be speaking out of turn to answer that question directly. But there are definitely some heart-related interactions that should be considered. And usually people with heart conditions, their doctors will advise them about caffeine intake.
Absolutely. And we'll end with, does caffeine deplete body of vitamins and weaken bones?
So there are some data about mineral homeostasis, and there are some studies that claim that they're challenging, and it partly gets back to sometimes is it the animal model that's really driving the data interpretation, and how well does that model humans? Is it humans? And like you saw, the coffee intake goes up with age, so does bone turnover. It's kind of bone strength loss. But there are some signals that, it potentially does alter mineral balance and could have, at least certain levels, some impact on bone integrity and mass and strength.
Awesome. Hey, well, Dr. Smith, can't thank you enough. Thank you so much for spending over an hour with us to share your expertise and all that information. Again, thank you for jumping on with us today.
My privilege.
All right. And just as a reminder, today's webinar will be uploaded onto our website early next week. As an attendee, you will get an email once the link is ready. Before we highlight a few of our upcoming webinars, I want to let you know about our upcoming NAS scholarship run presented by Viva Health. Registration for the April 20th scholarship run is open at alumni.uab.edu/5K10K. Join us for our 5K, 10K, and fun run, or take part virtually wherever you may be. All participants will receive a t-shirt and a finisher medal. Again, that link is alumni.uab.edu/5K10K. And be sure to come back for these upcoming webinars. On Tuesday, April 23rd, our The Science of series concludes with the Science of Sleep from A to Z. Join Dr. Justin Thomas as we dig into how much sleep is needed, the consequences of not enough sleep, and sleep disorders. On Wednesday, May 8th, we'll be hosting Between a Breadwinner and a Caregiver. Mary Meadows Livingston will be here to explore the struggle the sandwich generation faces. On Wednesday, June 26th, Dr. Alan Gorman returns for Workplace Avengers, Avengers Unite, how to recognize toxicity in the workplace and what to do about it, where we'll find out the signs of toxicity and what to do about it. And on Thursday, July 11th, we'll be hosting Finding Calm in the Chaos, 5 Strategies for Reducing Stress. Dr. Daniel Watson will join us as we learn how to understand the signs, symptoms, and impacts of chronic stress. Register for these and more at alumni.uab.edu/events. Finally, be sure to let us know how we're doing. The QR code on your screen takes you to a short survey. What did you think? What would you like to see? We'd love to hear from you. Once again, thank you for joining us. And as always, go Blazers.